Hi guys, Miss Griffin again. We're taking a look at Unit 5, Skill 4, Modeling Quadratic Word Problems. So please take a second to write down your essential question. This should have a question mark. And then we're going to take a look at example 1. So we're looking at modeling quadratic word problems. So we've got this problem with a football player attempting to kick a football over a goalpost. So you've got this guy trying to kick a football that's on the ground over and into this goalpost, right? So the path of the football can be modeled by this quadratic equation. So the path that this football takes is modeled by this equation, where x is the horizontal distance from the kick, meaning this way, and then y is the height of the football at any given point. So if x is like 1 foot, then the height is smaller than if it were maybe 10 feet away, right? Because you gain height as you kick it. And we're measuring in feet. It says sketch a graph of y equals h of x. So we're going to type this equation into our calculator. So you need your calculator in front of you, and we're going to sketch it. We're going to adjust our zoom settings so that way we can all see the graph kind of the same, or know at least what it should look like in the calculator. So we should go to hit tab to type in a equation. Mine's still on relation from the last video, and so I'm actually going to hit escape on this, menu 3, and this time I'm typing in a function, so choice 1. So if your calculator is doing the same type of thing, then you can easily change it by going to graph entry edit. So we have negative and then fraction. So I just did control divide to pull up the fraction. 1 over 225, move out of that, x squared plus fraction 2/3 x. And I hit enter, and it looks like it's a straight line, but if I zoom out, so let's change our window settings to be the same as one another. So I'm going to hit menu 4, and then I want to do my own window settings. I don't want to just necessarily zoom out. I just want to find my own settings. I know that I don't care about the ball if it's a negative distance, meaning the ball's going behind me. So my min is going to be 0 for the x. My max, I don't know, maybe say we kick it 150 feet horizontally. The scale, let's change it to 10, counting by tens. The y minimum, I don't care if it's deep in the ground, it's not going to bury itself, so I need to start at 0, a height of 0. I have no idea how high this might go, so I'm just going to try 40. If we need to change it, we can always change it. So go down to OK. Ooh, that looks pretty. Guess what? I planned it that way. But if you're not sure, you can start by zooming out first and then changing your scale appropriately. So you might want to jot those numbers down on the left-hand side of your paper. We did, again, 0, 150, 10 for the scale, 0, 40, and auto. And now we're taking a look at sketching this on our paper. So I'm going to just kind of take this, nope, false. Can I move it? Okay, I can. So I need to delete that little piece of writing if I can, but maybe I can't. Who knows? All right, so I'm sketching this. Whoop, whoop. This is my x-axis. This is my y-axis. Of course, it has arrows. And then I'm sketching my little parabola. And this is certainly at 0. I don't know this value yet, nor do I know the maximum height, but it's just a sketch right now. We can find out each of these things by using our calculator. Okay, so I'm going to find the other 0, meaning where it crosses my x-axis. So I'm going to hit menu, 6, 1. Lower bound, yes. Upper bound, let's hope I can scroll. Okay, so I might have to adjust my window because you can see I couldn't scroll any further. So I'm going to hit menu, adjust the max to be 160. Okay, now I should be able to scroll. 6, 1, lower bound, upper bound, ooh, it's popping up, is 150. So this point here is 150. I might also want to find that maximum, the vertex of this graph. So I'm going to hit menu, 6. I can do 3 for maximum, lower bound, upper bound. Make sure you go far enough to the right because you could see that it showed one value, but it wasn't quite the maximum. So I'm going to sketch that on my paper as well, and then we'll see what we need if there's any other additional information to answer the following questions. Okay, so I just finished my little sketch here, and I do need to write the equation h of x equals -1 over 225 x squared plus 2/3 x. So now I'm going to look at the next question. It says determine the vertex for h of x. Well, we just did that. Another way to have done that is to go to menu 6, 8 for the conics and then look at vertex. So we know that the vertex is at 75, 25. Again, vertex is the highest point. It says interpret this meaning of this vertex in the context of the problem. So remember that we're kicking horizontally. So this is the distance horizontally. So when the kick is 75 feet out, meaning horizontally, then the ball, I don't know why this doesn't stay connected, then the ball is at a height of 25 feet. And again, this y-axis is height. Next part says the goalpost is 10 feet high and 45 yards away from the kick. Will the ball be high enough to pass over the goalpost? Justify your response. So if I take a look at this next part, it says feet high and then yards. We have to change that 45 yards into feet. And we know that there are 3 feet in every yard, so 45 divided by 3 gives me 15 feet. So the question is when x is 15, what's the height? So we can do this by looking at a table. So you're just going to pull up the table in your calculator and look to where you see 15. It's easy to change your table setup by following these instructions so that you're not going up by ones. And I would say that your table should start at 5 and then go up by 5 each time. Start at 0, go up by 5 each time. That way you can find 15 pretty easily. Once you've done so, you'll notice that at x equals 15, the height is 9. But it says that the post is 10 feet high, so would he make it? No. The ball will not make it over because at 15 feet horizontally, it's only 9 feet high. Okay, let's take a look at the next problem. Similar situation, but we're talking about a baseball player this time, throwing a ball from the outfield towards home plate. The ball's height above the ground is modeled by this equation where y represents time in seconds. I think this should say where x represents time in seconds. So after a certain number of seconds, y is the height. The ball is initially thrown from a height of 6 feet. My goodness, I'm seeing so many typos. This should say ball. So sorry. Okay, so we're sketching a graph of this function. So again, I have the x-axis, the y-axis. You're going to type this into your calculator. You're going to adjust your window. You might want to zoom out first, see what it looks like, figure out how far, how wide you should go. Hit play when you're ready to see kind of a result. Okay, so this is what mine looked like after I've adjusted the window. I had 0 and 6 as my min and max for x, the scale of 0.5, 0 and 45 with a scale of auto for the y's. So it looked a little bit like this, and I'm asked how many seconds after the ball is thrown will it reach its maximum height, and what is the maximum height? So I'm going to look at my calculator to find out what the max is. This point right here, or in other words, the vertex. So remember, in order to do that, we're going to hit Menu, 6, and the maximum is choice 3. So I have to be on the left side for the lower bound, right side for the upper bound, and it comes out to be 1.5, 42. So I'm going to jot that point down on my sketch and then also take a look at answering the question itself. So we're asked after how many seconds is the ball thrown, will it reach its maximum height? So after 1.5 seconds, the max height is 42 meters. Then it says after how many seconds, or how many seconds after the ball is thrown will it again be 6 feet above the ground? So this was initially 6 feet off the ground. Sorry about that. And I'm asked again, when does it hit 6 feet again? So I have to figure out when is this going to be a y value of 6. So I can either look at the table or I can trace my graph. I can type in y equals 6 and look at where they intersect. That might be the easiest option. So I'm going to pull up another calculator little video here. So I want to know when does it hit y equals 6. So I'm going to hit tab, type in 6. I want to know when these cross the second time, not the first time. So I'm going to hit 6 and then intersection, lower bound, upper bound, and it happens after 3 seconds. After 3 seconds, it's a height of 6 feet above the ground again. I could have found that also by looking at the table, Control T. And then our next question says, how long was the ball above 25 feet? So somewhere in here we have 25 feet. And I'm asked how long does it stay above 25? So from this point up and around until this point, meaning what are the time lengths that happens between? So I need to also graph y equals 25 in the calculator. The reason I want to graph y equals 25 instead of just looking at a table is because I need to round to the nearest second. And so I'll get a more accurate answer if I'm doing analyzing and intersection than if I were to look at the table. So they're asking what graph, because I have multiple graphs on here, so I'm going to choose this first one, and the second graph will be here. I'm just hitting enter each time. Lower bound is here, upper bound. So I'm going to sketch this point down on my paper. It starts at 0.469, 25, and then I want the other one. So I'm going to just keep scrolling over, and it says 2.53, 25. Okay? So what this is saying is that it hits 25 feet above the ground after 0.469 seconds and after 2.53 seconds. But I want to know how long is that period of time. So from here to here in terms of the x values. So what I need to do is take 2.53, subtract 0.469, and then round to the nearest second. So do that on your calculator and round appropriately, please. So when I rounded, I found 2 seconds. So your main takeaways from today's lesson are being able to graph it in a calculator, zooming in, zooming out appropriately, and then just answering these follow-up questions based on like finding the maximum or the vertex, finding out when you cross a certain height or a certain time. If you have any questions, jot them down in the margin. Don't forget to do your practice problems. You will need a calculator to do so, so come ready, prepared in class for your practice.